Hi, welcome to Dissolved Chemistry. Let us continue our discussion on this preparation of haloalkanes and haloarenes. In the last video, we have gone in depth with preparation of haloalkanes from alkanes and alkenes. And we will take one example and then we will continue with the preparation of allyl halide. Okay, then followed by from alcohols, how we can prepare haloalkanes and by halogen exchange reaction. Fine. So let us start with one important question that. So you see here, when you take, right, like this substrate, okay, CH3, they will give in the examination, CH3 they write or just they will put it like this. It is understood that it's a methyl group, fine. So now, when you go for like addition of hydrogen bromide, simple if it is there. So when there is no condition is being mentioned here, okay, so then it should be understood that it is going to add according to Marconi's rule. Okay, now suppose specifically if it is mentioned here by writing this substrate, okay, this is very, very important. Make note of this double bond. Okay, and then what they will write is they will write like this HBr, and on the arrow mark they may put peroxide. Okay, or they may write as H nu. Okay, if it is so, then your product will be different, and that is your anti-Marconi's addition we call. Okay, or anti-Marconic. Okay, anti-Marconic addition, it is Marconi's addition we can call. Okay, or according to Marconi's rule, it is going to add. In the previous video, we have discussed in greater detail. Please go through that. Then you can understand what I am discussing here. Fine. So according to Marconi's rule, if it adds, right? If there is no any condition mentioned on the arrow mark, only HBr if it is written, then it is understood that this reaction will occur according to Marconi's rule, and you will be getting product as Br is going to add here. Okay, and H will go to this carbon, right? So H is going to here. We will see the mechanism also. And if the peroxide or like light, if it is mentioned specifically, so then for the same reaction, your product will be what? Br will go to the next position, means orthobromotoluene, cyclohexane you will get, and here you will be getting 1 methyl 1 bromo cyclohexane as a product you are going to get. And how we will get this one? Actually, what happens as a major product? You make note of this major product, right? So now, when the hydrogen halide adds, first is electrophile will attack. We know that one. We have discussed that in previous video in detail. So when it attacks, then suppose if it goes to this carbon, right? It shifts. So then what you will be getting? Two options will be there. So you will be getting H is added here and you will get this carbocation. Now suppose if this pi bond goes here and H plus adds to that carbon, so then form the carbocation will be what? But this is the carbocation what it is going to form. Hydrogen if it comes here. So then look into the stability of these two. So this is tertiary carbocation, it is secondary carbocation. And we know that tertiary carbocation is more stable. So therefore, what happens? You will be getting this as the major product when it follows the Marconi's rule, or when the conditions are not mentioned, only HBr if it is there in the reaction, if it is given. So then this will be the product. Please make note of this. This is very, very important entrance point of view. Next is, suppose if there is a peroxide, once again you will be seeing that it will follow the radical mechanism. As it follows the radical mechanism, then your major product will be 2 bromo 1 methyl cyclohexane as the product. This will be the major product. Make note of this in presence of peroxide or in presence of light we are going to get. Okay, so this is very, very important. So therefore it is not included in the last video. So therefore, I have included here. And now we will move on to how this allyl bromide or allyl halide is going to be prepared. Preparation of allyl halide. Fine. Now, first we will know what is allyl position. Fine. So you will be having a double bond, then followed by methyl group. Next to doubly bonded carbon is called allyl position. Make note of this. Okay, you should make note of this. See here, methyl group next to doubly bonded carbon on either side. Here also, if it is there, then it is also called as allyl position. Okay, any side. Okay. So with respect to double bond, alpha carbon is called allyl carbon. Make note of this. Very important. So now we will see this one. Now, what difficulties we come across with when such we want to brominate this one or halogenate this particular carbon. Okay, so now we know that already we have seen double bond is more vulnerable for the addition of hydrogen halide as well as halogen. Now, how to halogenate this group in presence of double bond? Okay, so which is very difficult, but still we can do that one. So that we will see. So we will see example. We can take, so this as an example. In this example, so double bond, then this sp3 hybrid carbon, that we call it as what? Allyl carbon. And this is also allyl position. Both are identical because with respect to double bond, they are in the alpha position. Fine. So now, how to bring this reaction, making sure that there is no addition to double bond. Okay. And your halo group should go to alpha carbon with respect to doubly bonded carbon. Fine. So to make sure of that, what you have to do, you take halogen bromine or chlorine. Okay, and you heat at high temperature like 773 Kelvin, approximately 500 degrees Celsius. At that high temperature, when you heat, so then what happens, instead of addition to this double bond, your bromine or chlorine will go to what? Allyl position. And this is how, keeping double bond intact, we can make halogenation of allyl carbon. Okay, and again heating at 500 degrees Celsius or 773 Kelvin means it is high temperature we have to maintain. The addition product also we may get. So therefore, to avoid this, what we can do is selectively we can brominate, or by using what? N-bromosuccinamide. Okay, we can do that also. Allyl position we can add by using NBS. Make note of this. Okay, so N-bromosuccinamide. Okay, so then also we can get the product as this HNu or hydrogen peroxide. You have to use as catalyst, and then we can get a selective product as allyl bromide. Fine. Preparation of haloalkanes from alcohols, we will see. From alcohols. Okay. So whenever I say alcohols, means here we have to substitute a hydroxyl group with halo group. That is our task. Okay. So that task we can achieve, okay, by using catalyst or halogenating agent as phosphorus halides. Okay. Phosphohalides, and we can use thionyl chloride. Okay, and we can use HCl. Okay, the dry gas, we can use HCl gas and your zinc chloride as catalyst, and then we can use thionyl chloride, phosphohalides, then HCl. Okay, so these are the three. Phosphohalides means, for example, you can take PCl3, PCl5, PI3, PBr3. So all these reagents we are going to use to bring the substitution of a halo group, to replace hydroxyl group with halo group. Okay, so we will see one by one, and how the reaction will progress and all that. And you can use thionyl chloride, SOCl2. Fine. So first we will see. Okay, CH3, CH2OH, ethyl alcohol we will take. And suppose if you take PCl5. Okay, so then what happens? You will be getting product as CH3CH2Cl plus phosphorus oxychloride is formed, plus you will be having what? Phosphorus oxychloride plus HCl. Okay, those are the other products what we get from that. Then when you use CH3CH2OH plus PCl3, and if you heat, okay, so then you will be getting CH3CH2Cl, 3 moles we will get, and you will be getting S3PO3, phosphorus acid we will get as a byproduct. And here, which is what? You should make note, when we use PCl5, you will be getting only one alcohol is converted into haloalkane, ethyl chloride. Whereas if you are using PCl3, so then 3:1 ratio product we are going to get. So therefore, it is more stable reaction. Fine. Now, suppose if you want to brominate, okay, or bromoalkane or iodoalkane by reacting with alcohol, means you have to prepare phosphorus bromide, okay, tribromide in situ, and phosphorus iodide is also prepared in situ. Meaning is what? In situ means during the reaction we will prepare, and immediately they are made to react with to get the product. Make note of this. And next is by using thionyl chloride, how we can bring this reaction. Fine. So suppose if you are using thionyl chloride, it is done in presence of catalyst pyridine we are going to use. Okay. So then the reaction will occur, and you will be getting CH3CH2 Cl plus SO2 plus HCl. One thing is this HCl and SO2 both are what? Volatile compounds. Okay. And they escape out, and you will be getting the product. And make note of this. Question will be raised on this particular aspect also. Right. Then next is important, that is dry HCl gas and your zinc chloride combination, which we call it as Lucas reagent also. Okay, we will be studying detail in alcohols also, right? So then how we can prepare that? One CH3CH2OH plus HCl in presence of zinc chloride. Okay, primary alcohols in presence of zinc chloride combine with HCl to give what? Ethyl chloride as the product. Okay, and now suppose if you are using secondary, okay, CH2 CH3 OH isopropyl alcohol if you take, and then also we need zinc chloride. In presence of zinc chloride, it will react and it will give the product CH3CHCl, okay, CS3, right? Now, when you go to tertiary, it is more reactive towards this particular reaction. Only if you use HCl, that is more than enough. Directly we can get the, you make note of this point, right? So if you are using tertiary alcohol, there is no need of zinc chloride. Directly HCl, if it is there, that is fine and good. You will be getting product. Okay, so make sure and try to remember this particular point. Okay, G1 zinc chloride is not required. So then order of reaction towards HCl and zinc chloride will be what? Direct hydrogen halide directly with reaction with alcohol. So tertiary will be more reactive. Zinc chloride is not required. Then followed by secondary, followed by primary. Okay, so that is how it is going to occur. Fine. This is all about how we can prepare haloalkanes from alcohols. Then next we will move on to means halogen exchange reaction. Okay, so that we will see. Well, last one is we will take Finklestein reaction. Halogen exchange means one halogen is being replaced with another halogen on the carbon substrate. So to get the new haloalkane, right? Finklestein reaction. So this method is used to prepare iodoalkane. Make note of this. Important. It is used to prepare iodoalkanes. Okay. And how this reaction is brought? You have to use RCl or Br. Okay. Combined with sodium iodide in presence of acetone. If you heat, so then what happens? There is an exchange of halogen, and you will be getting product as alkyl iodide plus NaCl, okay, as a byproduct. We will take one example, CS3, CS2, Cl plus sodium iodide. Okay, acetone we will use. Heat when you do, so then we will be getting CS3, CS2, I plus NaCl. So that is how we are going to get Finklestein reaction. Important, remember this reaction, fine. Then lastly we will see Swarts reaction, which is used to prepare fluoroalkanes. Okay, directly already we have seen in the previous video I have mentioned the direct halogenation, because fluorine is having more affinity for hydrogen. So direct when you go for halogenation, the reaction is more violent. Okay, to avoid that, we will use this alternate method. Okay, which is which we can bring under mild conditions. Okay, so what is this Swarts reaction? This reaction is used to prepare fluoroalkane. First, you make point. Okay, how we can do this one? We can use alkyl halide, alkyl chloride, for example, CS2Cl, and you have to take silver fluoride, or you can use mercury fluoride, or antimony fluoride you can use. Okay, SbF2. So any of these reagents you can use. Okay, to get CH3CS2F. Okay, plus AgCl. So this is how the Swarts reaction is brought, right? I hope you have understood the different methods of preparation. So two large videos we have done, because to cover the chemistry underlying in the preparation, it is very important, and you make sure that from alkanes again that will be repetition, because in hydrocarbons also you have to study. So therefore in both the cases it will be useful for you. And similarly preparation of haloalkanes from alkenes, again you are studying Markovitsov rule, anti-Markovitsov rule, peroxide effect. Okay, 1 to hydride shift, 1 to methyl shift, all that we are going to study in alkenes. Same thing here I have presented. You correlate and study, it will be very easy for you. Fine, thank you for watching this video, and please don't forget to subscribe our channel, and please share with your friends.